Okay. So meanwhile, others join. You people can complete the form, quiz form. I'll just paste it. 1 second. Yeah. I'm pasting in the chat window. You people can complete. Meanwhile, 1 or 2 seconds, we'll wait for others to join. Complete the quiz. Enjoy it for 3 days. Yeah, who is coming for offline? Anybody is reporting to offline classes? Or everyone wants only online? Anybody? Okay. So in the last class, we have started with last unit, that is transaction management. So in the last class, we have started with the module 5, that is transaction management overview. So in the transaction management, what we learn is how the database, whether read, if it is a read mode or if it is a write mode, how the transaction and how it should be done, what is the limitations we are giving, whether it is same way if we consider for a banking, um, they have restricted the transaction for one particular account. If it is within a bank, only 5 transactions. If it is outside other bank, then they have limited only for 3. Why? Because huge number of population, and if they start using more transaction, then the database charges has to be implemented, because by doing so many transactions, it will be increase in the storage space, as well as transaction in the this thing transaction part. So that's what we require, a transaction management. ಹೇಳಿ ಸರ್, ಹೇಳಿ ಸರ್, ಯಾಕೆ ಹೇಳಿ ಸರ್. ನನಗೆ ಕ್ಲಾಸ್ ಇದೆ, ಆಮೇಲೆ ಮಾತಾಡಲ್ಲ. ಹಾಂ 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 ಹೇಳಿ. ಹಾಂ ಏನು ಹೇಳಿ. ಹಾಂ 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 ಓಕೆ 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 Okay, sorry for the inconvenience, because sometimes what happens is we may not be knowing whether there are two parallel classes. That's the reason we have to attend the call sometimes. Okay, so in this part, what we do is transaction management overview. So how the transaction, that's what I was saying. If we consider a banking, for everything we have to store all the transactions in the database. And imagine if one person is doing more number of transaction and saving those transaction for years together, huge memory is required. So to avoid that, that's the reason the banking sector people have decided the transaction should not be done more than 5 if it is even inside or outside the ATM branches, other bank ATMs. That's the reason the storage space requires more. So in the same way, how to manage all these? So it is not only banking sector, even you can see your Amazon, Flipkart, whatever it is. Everything should be saved. So how long they have to save that? It's some that's what once every all the items are dispatched to us. Maybe some for some more months they may keep and they may discard. So why all these is required? To keep track the items have dispatched or not. In case if there are some any suppose if you are buying some mobile and they may say 1 year warranty or 2 year warranty, then they have to keep track all your details, because within if your mobile has damaged something, then they have to, if it is 2 year warranty, there will be no charges for that. So for that reason they have to keep track. In that case we require a transaction management overview. So then next we move on. Transaction concurrent execution of user programs is essential for good DBMS performance because disk access are frequent and relatively slow. It is important to keep the CPU humming by working on several user programs concurrently. So what is this concurrent thing we are doing is parallelly. So now how many of you are parallelly accessing this particular login? So even the Google Meet people also, they have restricted. They have set some properties. If it is more than, earlier it was more than 250. Now they have reduced it to 100. If more than 100 people are accessing same login, then they will be charged. So something like that, they have the transaction things. So that's what here the concurrent execution of user program is essential for good DBMS performance because disk access are frequent and relatively slow. It is important to keep the CPU humming by working on several user programs concurrently. A user program may carry out many operations on the data retrieved from the database, but the DBMS is only concerned about what is read-write from to the database. So what is the work of the DBMS thing? How the user program may carry out many operations on the data retrieved from the database, but the DBMS is only concerned about what data is the read-write from or to the database. That's what the transaction will be doing. How the data should be read to the database tables, how it should be retrieved from the database. If I am writing, where I have to write, whether I have to write a ROM, disk or storage, which part of storage, what is the location, everything we have to know. Because where I have to storing, if I want to retrieve, I should know the address. That's the reason from and to the database also, the transaction is required. In the same way, a transaction is the DBMS abstract view of a user program, a sequence of read and writes. So what is transaction? A transaction is the DBMS abstract view of a user program. A transaction is a DBMS abstract view of a user program, a sequence of read and write. So what is a transaction? Transaction means transaction in the DBMS abstract view. If I just want to say in one word, what is our transaction with respect to database management system is a sequence. I may say a sequence of reads, which can be reads and writes. So then we call that as a transaction. And abstract view of the user program, how the user is writing the program, whether he is writing the program 2 times read, 1 time write, or write 2 times or read 2 times, like this we do, then that is what is called as a transaction. Then concurrency in a DBMS, users submit transaction and can think of each transaction as executing by itself. Concurrency is achieved by the DBMS, which interleaves actions read-write of DBMS objects of various transactions. So concurrency of a DBMS, user submit transaction and can think of each transaction as executing by itself. Concurrency is achieved by the DBMS, which interleaves actions read write of a DBMS object of various transactions. Each transaction must leave the DBMS in a consistent state if the DBMS is consistent when the transactions begins. So consistency means what? What is the meaning of concurrency? Means parallel. Maybe if 100 people are using, if it is beyond that, how? So same way you take concurrency means if the database. Suppose you think that 10th results are out, and nowadays everyone started using online, and everyone want to see the results online only. Then what we do here, the server should manage lakhs to people accessing the database at one particular time. Means that's what the concurrency is. Concurrency is achieved by the DBMS, which interleaves actions. Maybe sometimes, if you let us assume that 10th results are out and everyone wants to see their results, then what you people will be doing? You give your USN. When you give your USN, um, when you give your USN part, then what you people, what you'll get only your result, not your friend's results. So then what is the operations we are doing on the database management? You are just reading, and you don't have an authority to write or change your marks. Only you can read, only you can view. So that's what is one type, that is a read. Now, let us say that you have an option of sending a mail to the any people saying that your name is missed with the initial. So then, what type of operation we do? We do with the write operation. That's what write of DBMS, object of various transactions. So concurrently, we can do read write of a database object. Each transaction must leave the database in a consistent state if the DBMS is consistent when the transactions begin. So what we do, each transaction must leave the database in a consistent state. So consistent state means what? That's what. Let us assume that whatever changes you have made. So now suppose if we are employees here, what is a authority I have? I can only view some details. Same way your websites. So we cannot change the details in the website, though all the details are present. Now my experience is there, my details, everything is there in the website. Then the same should be there. So how many staff are there in the college? Maybe more than 200. So all 200 people, format should be same. Means consistent. Should be staff name, what size should be there. All these should be consistent. Same way like your project reports. So at the end of your sixth semester, you start writing a report. You will be doing one project and you start writing the report. When you write the report, a report should be consistent. The format should be same. The front heading should be same. Front page should be same. All these we try to do it in the consistent part. Means it's all 60, all 50 the report should be, contents will be different, but the formats will be same. Like when you go for a hard bind, all MCA 6 semester colors are parrot green. So all these are consistent. Why? To identify uniquely which brand student it is. So that's the reason university has been done with the each transaction. So what we are doing, each transaction must leave the DBMS in a consistent state if the DB is consistent when the transaction begins. So then DBMS will enforce some interchanges depending on declared in the create table statement. Beyond this, the DBMS does not really understand the semantics of a data. So how the data is, so now suppose you think that the table what you have entered, first is your USN, next is your name, next is your third semester. Let us assume that you have entered first semester first mark, second semester first mark, third semester first mark. But the database will not understand what are all these. It will only understand those are numbers. So that's what here the semantics of the database will not be understood by the database, but human have to know what it is. So example, it does not understand how the internet interest on banking account is computed. So how the even the database will not be knowing how the calculation, how the interest is being given for the person having an account there. that will be all calculated. That's what you can see with respect to your Excel sheet. What we do, we calculate, you can just enter the details, but automatically will the Excel will calculate your average marks for 3 internal marks? No. Then staff has to sit and give the formula there, how to calculate the best of 3, then convert it to 20, convert it to 10. We have to do it. The database will not be doing that. So that's what is semantics of the database will be not understood by the any database, but human has to do some changes. So that is what here interest of the bank account. Similarly, the interest of the bank account is computed by a banking employee, not the system or not the database. So in the same way, issues with respect to database today, effect of interleaving transaction and crashes. Suppose I'm using now your thing. So we heard this so many times. When I asked you people to show the DBMS lab programs, you people will say my system is not working, my hard disk is not working, I have not inserted software. So many reasons you give. That is okay because you're showing me the programs. But imagine if the banking database crashes, then how should they retrieve all the database? So then leaving. So in between, we leave the data and come back again. Today, my class is somewhere, and today I'm leaving, then coming back to the next. Then these are the issues, effect of interleaving transaction and crashes. That's what the issue is. Then concurrency in the DBMS. Then atomicity of the transaction. A transaction might commit after completing all its action, or it could abort or be aborted by the DBMS after executing some actions. So that's what the atomicity. Atomicity means what? Either suppose if I am doing, that's what if the same example what I gave you in the last class, you're doing some shopping and you have purchased a mobile of around 50,000, and you have transferred your 50,000 to the account of Amazon, let us assume that. And before the acknowledgement comes from the Amazon, your internet has disconnected. Then what we have to do? So that type of problems we have to address. That is what is called as atomicity. What is this atomicity? A transaction might commit after completing all its action, or it could abort or to be aborted by the DBMS after executing some action. Very important property guaranteed by the DBMS for all transaction is that our atomicity. What is this atomicity is? Either you do the transaction or you don't do the transaction. That is, user can think of an act as always executing all its transaction. Action in one step or not execute any action at all. So what is this atomicity says to us is either you execute or you don't execute. So that's what even you people were saying, because you didn't use commit command when you are executing the program, or and whatever you have done today is not saved. So that's what here, when you use commit, means what? All your work, whatever you have done will be saved. So that's what here atomicity means what? Action in one step. Either you execute them in one step or not execute any actions at all. So that's what here atomicity says. Execute or don't execute. Do one step or don't execute. So that is what is the atomicity. So DBMS logs all actions so that it can undo the action of aborted transaction. So what is DBMS log says to us? So DBMS log all transactions, all actions, so that it can undo the action of aborted transaction. So that's what here log all actions so that it can undo the actions of aborted transaction. So whatever the logs were there, now you can see your history. So whatever we have done today, quick, what we have done yesterday, I suppose let us assume that I have opened some website and I don't remember the URL, and tomorrow, yesterday I was open, today I want to again view what I have, because I have not completely read. I want to check again. What is the option? We go back to the history and check there and do it, because we can't remember everything. But sometimes what we do is we try to delete all the things. Then we cannot retrieve them, or I cannot visit the same URL again because I don't remember so many URLs are there. So then DBMS logs all actions so that it can undo the action of an aborted transaction. Okay, so let us consider one example. Consider two transactions, that is T1 and T2. Let us consider two transactions, T1 and T2. So begin, I want to add 100 rupees to the account A, then subtract from account B and end. So in the same way, transaction 2, begin, multiply interest of 6% to the account A as well as account B and end. These are the two transactions. So now let us intuitively, the first transaction is transferring 100 rupees from account B to account B account to A's account. The second is credit both the accounts with a 6%. So what it is being done? So from account B, 100 rupees should be withdrawn and deposited to the account A. This is first transaction. Whereas in the second transaction, what we are doing? We are adding the 6% to A and 6% to B. So that is what crediting both accounts with 6% interest payment. There is no guarantee that T1 will execute before T2 or vice versa. So how the execution, we don't know whether T1 will execute first or T2 will execute next. If both are submitted together. So now suppose you think that now at 11:50, you have, let us assume that two staff have started taking a class. Then which class will you people will join? Then this was the conflict before when we were creating a separate logins for each of us. Each staff was creating a separate. But now that problem is ruled out because the same login is there, but staff are only changing. So that this ruled out two staff taking the class at the same time. So there is no guarantee that T1 will execute before T2 or vice versa. If both are submitted together, however, the net effect must be equivalent to these two transactions running serially in some order. So that's the reason the effect of these two, which one should execute first, which one should not execute first, that also should be decided. So that is what is called as a two transaction. So now consider a possible interleaving, that is a schedule. So in the same way, you can see scheduling. What is the scheduling? You would have seen, so there are so many scheduling, priority scheduling. In the data structure, we have seen so many scheduling, round robin, first come, first serve. Samely here in the transaction also, which transaction should execute first and which one should be next. After that, which one. So this order is also very important. So now the same way, what the two transaction we have seen, deposit 100 rupees from, withdraw 100 rupees from B and deposit to A. And one more transaction was adding the 6% for both the accounts A and B. So now this is what we are doing. So here we can see in the first part, first 100 rupees is deposited to A. Then 6% is added to A. Then from B it is been withdrawn. Then from and again add to 6% to B. This is okay, but what about if we do something like this? If I change the order, so that's what we were discussing, the order of the transaction. If A, then first write to A, write to A, again write to B, write to B. That's what here read, write is called as a transaction. So here what we are doing, if I change the order of the transaction. So T1 we are adding to A and 6% we are adding to A and 6% we are adding to B. Then again B withdraw 100 rupees from B account. So if we follow this one, so then which one is this? So the DBMS views the second view. That's what here read write. So what was there in the earlier in A, we are reading. Then write. What we are writing? Adding 100 rupees to account A. That's what read once, then write. Okay, here also, what is there in A? So some value will be there in A, and add 6% to A. So the same way, B also, read B and write B. Read B, then write B. That's what here we do with the B. So then, in the same way, what we do here, again, next we have a read B, write B. Subtract 100 rupees from, subtract 100 rupees from B. So the same way how we have in the operating system different forms of okay. Uh, uh, we have a scheduling transactions. One is one second. I'm just checking out. Okay, serial schedule. Schedule that does not interleave the action on different transactions. Serial scheduling means what? Now let us, if I take two algorithms, that is linear transaction, linear algorithm and binary. In linear, what linear search and binary. In linear, what we do, we go check one element by element, one element by one element, one element by element. That is what is called as a serial schedule. Schedule that does not interleave the action of different transactions. That is what is called as a serial schedule. Then equivalent schedule for any database state, the effect of executing the first schedule is identical to the effect of executing the second schedule. So the equivalent schedule, serial schedule, the schedule that does not interleave the action of different transactions. Then equivalent schedule for any database for any database state, the effect of executing the first schedule is identical to the effect of executing the second schedule. That is what is the equivalent schedules. Next is serializable schedule, a schedule that is equivalent to some serial execution of the transaction. Note, if each transaction preserves consistency, every serializable schedule preserves consistency. So that's what here scheduling transaction. So what this scheduling transaction will be doing, that is serial scheduling, equivalent scheduling, and serializable scheduling. Serial means one after the other, like your FM radio. So what is this FM? Whatever they mm, give the time slots. Now this event, after that next event, next event. So like that, one after the other, we have to see. That is what is a serial. So then what is equivalent schedule? For any database state, the execution, the first, something like your equivalent. So any database which the first schedule, if it is identical, so now equal, we have a, if we speak about the operator, we have a equal operator, then that is what is called as a equivalent scheduling. Then serializable scheduling, a scheduling that is equivalent to some serial execution of the transaction. So if you see in your C programming, if we speak about functions, so if you are using functions, if you are calling a function, what type of parameter you are passing, how many parameters you are passing, it should be defined, it should be declared, all these we see. So the same way here in the DBMS also, a schedule is a schedule that is equivalent to some serial execution of the transaction. That is what is called as a serializable schedule. Note, if each transaction preserves consistency, every serializable schedule preserves the consistency. That is what is the serializable schedule. So the anomaly is what we have with respect to interleaved execution. So reading uncommitted data, that is read-write conflicts, or dirty read. So we have a thing called as a dirty read. So what is this is, suppose let me see that your transaction one, what it is doing is it is reading a account and writing to a account. And after some time, transaction 2 also is reading a and writing a. Then you are using a commit command. After this, your B account is been read and B account is been writing. Then abort. So we are doing this sequence of operation. Then this type, what we do, we are calling it as a dirty read. So in the same way, unpredictable, unrepeatable read. So now you have just read the account A in a transaction A. So then you have just read and you have not written anything. Meanwhile, the transaction 2 is reading as well as writing. Then commit, then reading, writing. Then again the conflicts here. Read, write, because here you have not added 100 rupees here. Before you are adding your adding 6% interest to the A, and here you are again reading A. What was there? 100 only, and you are not changing A. So there is a problem here. You can see here you have just read and it is left in between, and you are doing one more transaction with the same account, and here again. So see, this type of read is called as a read-write conflict. The next one is continued with the same read-write. Now we have one more thing called as a write-write conflicts. So what is this write-write conflict is, now you are doing a transaction writing. You are writing into the database. Now you can see, because nowadays we started sharing the drives. So then I can also write at the same time. Even you people can also write at the same time. So that is what write conflicts. Suppose if you are doing some changes in the same account, suppose let me say there is one account, my account, and I have opened it as a shareable, and something like 2 people can operate, you and your mother. Let us assume that. Then even you are withdrawing 5,000, the balance in the bank account is 5,000. Even you are withdrawing 5,000 and your mother is also withdrawing 5,000. Should that be happening? Because the balance is only 5,000 and both of you are withdrawing 5,000 at the same time. Then that is a conflict there, because how the database or how the bank should be doing such type of conflicts is called as a write. You are writing something, both the accounts you are writing at the same time. So write account to write to A, write to A, write to B. Then you are writing to B. So then this, you can see here only writing is been done. There is no reading. Whatever is there, you are just writing. So then that is called as a write conflict. So next we have something called as a lock to avoid this. So now we have these anomalies, that is dirty read is there, as well as read-write conflicts is there, then write conflicts is there. So to avoid all these, we have something called as a lock. Unless I complete my transaction, though I have shared, means even I can use, my mother also can use, but still when I am using, my mother should not be allowed. Such type is called as a lock-based concurrency control. So in that lock-based concurrency control, we have a two-phase locking, that is strict two-phase locking, strict 2PL protocol. Each transaction must obtain a shared lock on object before reading and exclusive lock on object before writing. So now what we are doing here is, there are some locks available. So if you are reading, you have to use a shared lock. If you are writing, you have to use an exclusive lock. So these are the two locks can be used when we are concurrently doing the operation. If it is reading, no problem, because you are just reading, you are not editing anything. But only problem comes when both of you are writing. Both of you write at the same time for the same bank, then it will be a problem. So in that case, we are using something called as a lock. And there are two different locks being used. So each exact must obtain a shared lock on object before reading and exclusive lock on object before writing. All locks held by transactions are released when the transaction completes. So if an act holds and X locks on or object, no other can get a lock S or X on that object. Suppose if A is one account and both of you are using, until unless what type of lock you have used, whether you have used a shared lock or an exclusive lock. Shared lock is used for reading. You're reading a minimum balance in your account and you want to withdraw the amount, then you can use a exclusive lock. So that's what here strictly two-phase locking is required, and the strict 2PL protocol should be followed. So strict 2PL lock, only serializable schedule. So serializable schedule means one after the other only should be allowed, where the lock based concurrency control allow this 2P locking will be allowed where in which type of transactions, in the type of serializable scheduling. What is serializable scheduling? Serializable means what? One after the other. First Asta should execute, next is next person, next is next person, like this one after the other. So then such type of thing we are calling it as a serializable schedule. And the lock based concurrency, because there should not be dirty write, read write, write conflicts with respect to database transaction. In that case, we are using something called as a locking. And again in locking, there are two-phase locking. One is shared lock and exclusive lock. So shared lock on object before and exclusive lock on object after. So we use a S lock for reading, X lock for writing. Now let us see how the abort transaction is being done. If a transaction TI is aborted, all its action have to be undone. Not only that, if TJ reads an object last written by TI must be aborted as well. Most systems avoid such cascading aborts by releasing a transaction's lock only at a commit time. If TI writes an object, TJ can read this only after TI commits. So that's what here. Now I am reading, I am taking one object. Until unless I leave, others cannot use that. So that's what here. TI writes an object. It is writing to a particular object. TJ can read. If I am reading, n number of can read, only reading. But when we are writing, only one people should use that object when you are writing. That's what here. TI writes an object. If I is writing, then J can read, no problem. Only after TI commits. So I am writing something. If I am writing and if you open the same thing and you are reading, only one line is there, because still I am writing the second line. If I complete page, then only you can, once I commit, then only you people can read. So that's what same like your question paper. If only one question I have given in your question paper, and till I complete all 8 questions, you cannot start writing the questions, because you may not study the first question, you would have studied 5th question. Then you have to wait until complete question paper comes to you. So the same way here, TI. In order to undo the action of an abort transaction in the DBMS, must maintains a log in which every write is recorded. This mechanism is also used to recover from system crashes. All active acts at the time of crash are aborted when the system comes back. So that's what is called as a crash. In case if something happens, then I have to retrieve it back. So in that case, these logs will be helpful. Next one is a log. The following actions are recorded in the log. That's what you can see. Even in our laptops also, what I have opened today, quick links will be there. So what are all the transactions opened, what is a log, everything will be there. That is what is a log. And the following actions are recorded in the log. TI writes an object, the old value and a new value. Log record must go to a disk before the changed page. TI commits are about a log record indicating this action. Log records are chained together by exacts, so it's easy to undo a specific act. Log is often duplexed and archived on a stable storage. All log related activities and in fact all CC related activities such as locking, unlocking, uh, commit, read, all these also dealing with the deadlocks, etc. are handled separately by the DBMS. I'll stop here. We'll continue in the next class. Before I stop, so what we have done today, let us revise. So we have started with the transaction. So what is a transaction? So concurrent execution of user program is essential for good DBMS performance because disk access are frequent. So now how many times we open the memory? We open so many times. Now how many times you open your laptops? How many times you open your mobile thing? And in mobile also, nowadays most of our communication starts only in the WhatsApp. So how many times we use per day opening WhatsApp, and where is WhatsApp? Again, WhatsApp is in the database. How which database is frequently accessed? Because that's what here you can see. Because disk access are frequent and relatively slow. So that's what I was saying. You have a hard disk and processor in between, because hard disk is slow and processor is very fast. To make the compact between these two, we have a in between thing called as a cache memory, because disk access are frequent and relatively slow. It is important to keep the CPU humming by working on several user programs concurrently. Now we cannot make the CPU to wait. So then that is what is called as a transaction. A user program may carry out many operations on the data retrieved from the database, but the DBMS is only concerned about what data is read, write to and the database. That's what where you are reading, whether you are writing into the cache memory or whether you are writing to the hard disk, whether you are writing to the main memory, or you are fetching the data from the main memory or hard disk. So that's what here from and to. Then what is transaction? Transaction is a DBMS abstract view of a user program. A sequence of read and writes is called as a transaction. I may have anything. I may read, or I may say write. So I can do any sequence. But within that sequence, what will be there with respect to database? We will be having only read and write. So that is what is called as a sequence. A transaction in the DBMS abstract view of a user program, a sequence of read and writes. But then what is concurrency in the DBMS? Users submit transaction and can think of each transaction as executing by itself. Concurrency is achieved by the DBMS, which interleaves actions read, write of a database objects of various transactions. So each transaction must leave the database in a consistent state if the DBMS is consistent when the transaction begins. So that's what. Now, if I've started a class, the network should be there. Along with that, the Gmail should be opened. You should have a Google Meet app if you are using mobile. If you are using your laptop also, there should be a software. All these we have to see before we start the class. So that same way, when we are using a database, it should be consistent state in the DBMS. Then DBMS will enforce some ICs depending on the declared what we have declared in the DBMS, whether create table statement, whether to write, read, whether to insert a value. There will be so many things. And if I'm inserting into the table, how many values I'm inserting, all these are there in the create table. So beyond this, the DBMS does not really understand what the semantics of database. That's what I was saying. Your USN, your name, first semester subject 1, second semester subject 1, third semester, but the DBMS will not understand what the data is. Only the human being can understand what the semantics, what the data inside is, what is it, whether it is third semester marks, or whether it is second semester marks, or whether it is first semester marks. The database cannot understand all those, but Only the human being can understand. Same way, even in the banking account also, the interest for the bank cannot be calculated by the database. We have to give the formula in the database saying that how much interest should be calculated. So like this, there are so many issues with respect to a database, that is interleaving transaction. In between I leave, then how should be my database? Sometimes if my database get crashed, how should I operate this? All these we see in the transaction, and continue this in the next class. One second. Okay. Asta, answer your attendance. Asta. Answer your attendance. Asta. Abhinav. Aishwarya.
Present, ma'am.
Ambrish.
Yes, ma'am.
Anu.
Present, ma'am.
Arbaz. Arjun.
Present, ma'am.
Ashok.
Present, ma'am.
Benita.
Present, ma'am.
Bhargavi. Bhavishya.
Present, ma'am.
Chaitra.
Present, ma'am.
Deepmalai. Diksha. Deepika.
Present, ma'am.
Deepika.
Present, ma'am.
Deepika LG. Murli Krishna.
Present, ma'am.
Ma'am, Deepika MB.
Deepika MB. Mat.
Present, ma'am.
Gangubai.
Present, ma'am.
Gujiya.
Present, ma'am.
Darshit.
Present, ma'am.
Junjar.
Present, ma'am.
Kavya.
Present, ma'am.
Kishore. Lata. Lata. Manish.
Present, ma'am.
Manisha.
Present, ma'am.
Manjunath. Manjunath. Nayana.
Present,
Yes,
ma'am.
ma'am.
Present, ma'am.
Nayana present. Manjunath present. Nilanjan. Pavitra.
Present, ma'am.
Nishant. Nishant. Maithili. Priyanka.
ma'am.
Priyanka.
Present, ma'am.
Pavan. Akash.
Present, ma'am.
Rajeshwari.
Present, ma'am.
Rakesh.
Present, ma'am.
Ramya.
Present, ma'am.
Rashmi.
Present, ma'am.
Ravi. Ravi. Rizwan.
Present, ma'am.
Vishal.
Present, ma'am.
Savita.
Yes, ma'am.
Shruti.
Yes, ma'am.
Sneha. Spurti.
Yes, ma'am.
Srinidhi.
Present, ma'am.
Present, ma'am.
Srinivas.
Present, ma'am.
Sunil.
Present, ma'am.
Vaishnavi.
Present, ma'am.
Winnie,
Present, ma'am.
you received your marks? Any doubts in your marks? Deepika LG, what's